Hey class, it's chapter 3. This is Mrs. Norris and we're going to do the first video for chapter 3. You should have your note page out. We're going to record our notes on the note page. So we're going to start with a warm-up just to make sure that we remember how to graph lines. We're going to graph these 6 equations. The first 3 you're going to put on individual coordinate planes, 1, 2, and 3. And 4, 5, and 6 just go ahead and graph on one coordinate plane. My suggestion is that you remember that this is the y-intercept. It's a point. And this tells you to go up 3, right 1. That's how you graph the first 3. These 3 you're going to graph most likely using the cover-up method or the x and y intercepts. Take a minute, pause the video, and work those out. Okay, hopefully you have those 6 lines graphed on your handout. Next thing we're going to do is we're going to fill in some of our definitions, starting with a systems of equations. Systems of equations are a set of 2 or more equations that use the same variable. And a linear system is a system where the graph of each equation is a line. Okay, obviously a linear system means we have 2 equations and the graph is the line. We use a brace, or remember this is called a curly bracket. That's what you're going to fill in on your handout. It's used to keep the equation system together. It's important that when you list a system of equations that you put this little curly bracket off to the left. Okay, take a minute, get your note page filled in. Pause if you need to. The next part of your notes is to understand that a solution is an x and y value that makes all the equations true. So it can't just satisfy one or the other, it has to satisfy all of the equations. And one way that we're going to solve these in this section particularly is to graph them. When we graph them, we're going to find the point where they intersect. This intersection point is the solution. So let's start with a system that looks like this. When we graph this, we first need to get it into y-intercept form. Now if you look at these, I would be okay with you graphing the second one using intercepts, but let's just practice moving the variables around. So let's start with equation 1. Equation 1, we need to solve for y, remember, to get it in y-intercept form. So we're going to subtract x from both sides. Subtracting x from both sides gives me negative x plus 2, and it cancels here. Then we're going to divide all 3 terms by 3. We're going to get y equals negative 1/3 x plus 2/3. In equation number 2, which we see up here, we're going to first, if we look at this, remember we're trying to get y by itself, we're going to subtract 3x from both sides, leaving us with 3y on this side, and a negative 3x minus 6 on this side. Remember, it's important that you write the equation with the x part first. Okay, usually we put this in the back, but because we want it to look like y equals mx plus b, we're going to put it in the front. After we divide all 3 terms by 3, we get y equals negative x minus 2. Graphing these using this is our y-intercept, down 1 over 1. This is our y-intercept, down 1, right 3. We end up with 2 lines that look like this. When you graph a system of equations, if they do have a solution, you should get an intersection point. In this example, they intersect perfectly at negative 4, 2, so that is what our solution is. Using a ruler is really important when you graph these lines in order for you to find the perfect solution or intersection point. Okay, if you plug in x equals negative 4 and y equals 2 into this equation and into this equation, you will see that it equals and works. So it makes both equations true. Alright, here's your work for plugging in. We get negative 6 equals negative 6 when we plug it into this equation. When we plug in negative 4, 2 into this equation, we get 2 equals 2. Notice they went back to the standard form or the original form when they plugged in. They didn't use the fraction one. It's okay either way, they're both the same equation. Just make sure you plug your x and y values back in. Okay, you should be on number 9 in your handout. I want you to go ahead and try one of these. We're going to graph these two lines here that make up this system of equations. So go ahead and pause and try number 9. Now, if you look at these equations, it's easiest if you solve for y, especially for this one. The second one, you can use the intercepts if you want to. Take a minute and graph these two lines, please, on your coordinate plane. Okay, after you graph those lines, you should have something like this. And you should recognize that the solution to this system is the intersection point right there. If you look closely, you'll notice that these two lines intersect at 1, 3. So your solution is the point 1, 3. If you plug in x equals 1 and y equals 3 into both of these equations, you will notice that they hold true, that 1, 3 is a solution. Okay, now the next thing we're going to do is we're going to classify systems. So it's important that we understand these three categories. Watch these next 3 slides for just a minute, and then you can work on number 10, the matching, on your handout. So the first type of solution is called independent. It's when the lines intersect in just one point. The solution is independent. There's only one solution. The next type of solution is called dependent. It happens when your solution ends up with 2 exact lines that cross over each other, as in this example. We say that these lines coincide. When the lines coincide, every x and y value is a solution. So we say that the solution is dependent. The last type of solution is called inconsistent. In other words, there is no solution. This happens when the lines are parallel. So you can see that these lines are going to have similar slopes or exact same slopes and a different y-intercept. So let's start by putting all 3 pictures together. The first type of solution is the independent solution. It has one solution and the lines intersect in exactly one point. The next type of solution is the dependent solution. It's for when there is no unique solution because all points work. We say that the lines coincide. And the last one is called the inconsistent solution. It has no solution because the lines never intersect because they're parallel. So make sure you do the matching exercise for number 10. Pause if you need to. Okay, let's try to classify systems without looking at the graphs of them. Let's do it just by simply comparing slopes and intercepts. So let's fill in the steps there. Step 1 is to solve for the slope using slope-intercept form. In other words, get it in y equals mx plus b. Step 2 is to write clearly what is your m and b for each equation. What is your slope and what is your y-intercept? Step 3 is to compare those values. Okay? So if they're independent, they're going to have different slopes. If they are dependent, they're going to have equal slopes and equal y-intercepts. And if they're inconsistent, they'll have equal slopes and different y-intercepts. So let's try one of these. I've already typed this out for you on your handout. If these were the 2 equations I have and I need to classify them, the first thing I'm going to do is to rewrite them each in y equals mx plus b form. The first equation, this one, is already in y equals mx plus b form. So my slope is 3 and my y-intercept is 2. The second equation, written over here, needs to be rearranged. We rearrange it, we add 6x, we divide by 2, we get y equals 3x plus 2. Notice that these are the exact same equation. Not only do they have the same slope, they also have the same y-intercept. So we say that these lines are dependent. In other words, they're the exact same lines or they coincide. Okay, we'll practice a lot more tomorrow. Have a great night.